This is the second tutorial video about the agricultural risk management tool of crop rotations, also referred to as RotationARM. The first tutorial video covered correct data entry into the tool. The second tutorial will focus on the interpretation of basic results. The overall purpose of the RotationARM tool is to assist farmers and agronomists to evaluate and compare the performance of their current cropping strategy to potential alternatives. In this video, we will start off from the pre-filled RotationARM section and exercise workbook as completed in the first RotationARM video. This page presents you with the overall results for the reference cropping system. Section A first summarizes all the parameters that we selected in the tool. It shows the crop rotation we selected, the sowing rule, the fertilizer application rates, and also further structural characteristics of the cropping system, such as the scheduled cropping intensity. Directly below, Section B provides us with the annual performance results per hectare for 10 different results indicators. Thereby, the annual performance has been calculated as the average performance over all 60 simulated years from 1962 to 2022. The blue line shows the results for our specified cropping strategy. Instead, the green and the red lines show results for the cropping strategy that performs best and worst on a selected results dimension. By default, this refers to the cropping strategy with the best and worst gross margin. However, by clicking on the blue button, you can display the best and worst cropping strategy for other dimensions. Those are listed here in the middle. So, for example, we could be interested in changing the green and red line to the best and worst crop rotation in terms of crop water uptake. As you see in the background, the green and the red line have changed, while the blue line remains unchanged in terms of the actual values displayed. When looking at the specificity of the results, we can first note that we achieved an actual cropping intensity of about 0.7 crops per year, which is of course much lower than the nominally scheduled cropping intensity of about 1.25 crops per year. This is seen here on the first dimension, the actual achieved cropping intensity, whereby on top we have the nominally scheduled cropping intensity listed as 1.25 crops per year. Given our conservative sowing rule of always waiting for a 75% filled soil profile, we often simply leave seasons in fallow instead of cultivating the scheduled crops. That is why instead of having the high scheduled cropping intensity, we only achieve a lower actual cropping intensity. A benefit of this approach to always wait for a lot of soil water is that we never observe any crop failure. So the crop failure fraction is 0. Further, we also observe that we have a downside risk of our reference crop rotation of 0, which means that all grown crops achieve a higher gross margin than 250 Australian dollars per hectare. When switching back the priority indicator to gross margin and considering the performance of our cropping strategy in terms of the annual average gross margin it achieves, we see that we are generating about 1,000 Australian dollars per hectare. We can also identify by considering the red and the blue line that this is much better than the worst cropping strategy in this location and soil conditions, which only generates around $250 per hectare. But it's also still much lower than the best achievable gross margin, which is at about $2,300 per hectare. Another relevant results dimension that we exemplarily will discuss is the quantity of water lost via runoff, drainage, and evaporation. For this, I changed the priority indicator to water loss. It is desirable, of course, to keep water loss low so that limited water resources are used for crop growth. our cropping strategy loses on average about 440 millimeters per hectare, while using about 140 millimeters per hectare for crop growth. When comparing this to the best and the worst performance in this location and under these soil conditions, we can identify that we are at a roughly equal distance between the cropping strategy with the lowest water loss, that is about 380 millimeters per hectare, and the cropping strategy with the highest water loss with about 530 millimeters per hectare. At your own time, you may want to explore further results indicators listed in the graph, as it is in the end a very personal decision which kind of results indicators are most important on your farm and for your own personal circumstances. Again, we will note down the main performance in the exercise workbook. For this, we scroll to the next page, on page 31, and we fill out the column for the current cropping strategy. I have now completed the first column in the exercise booklet with the major results for our reference crop rotation. As the next step, we scroll down to section C, where we can see more disaggregated results separated for each crop. The box plots presented as the first figure are subdivided into two sections. The left-hand side show results for all seasons during the full 60 years of analysis. Instead, the right-hand side presents only results for the seasons with the selected climate conditions. In our example, we had specified to display results for extremely and moderately dry seasons. When comparing the left and the right-hand side, we can identify that the median yield is much lower in the dry seasons than when we make the statistics for all seasons. Particularly thereby the winter crops chickpea and wheat suffer strongly under the dry conditions in our current cropping system. Overall, we can identify that as a result of our conservative sowing rule, we achieve very high crop yields for all crops. The table below shows the corresponding planting frequencies. Again, on the left-hand side, we have the planting frequencies for all seasons, whereby on the right-hand side we have the planting frequencies for only the selected seasons, which in our case were extremely dry and moderately dry. When looking at the data in a bit more detail, we see that sorghum is planted with the highest proportion of 78% of the scheduled occurrences. Instead, chickpea is planted most rarely, and we have specifically only 26% of the scheduled occurrences that are actually planted. When instead looking at the planting frequency in dry conditions, we see that all crops are sown less frequently than in overall conditions. Thereby, particularly the winter crops wheat and chickpea observe a stronger reduction in their planting frequencies. When scrolling further below, we are provided with a time series plot that has all 60 years of analysis on the x-axis and crop yield on the y-axis. The pink background highlighting shows those seasons that are experiencing extremely dry or moderately dry conditions. So those seasonal climates that we had specified as our focus. The dots show seasons with crops harvested, and we can see that chickpea was sown most rarely, with a particularly long period between 1999 and 2010 that never observed suitable moisture conditions for sowing. We can further observe that wheat and sorghum were characterized by a large variability in yields by the high fluctuation in the lines towards the up and towards the bottom. Instead of only focusing on crop yield, we can also switch to display any further results indicator of our interest. You can again choose from the options displayed here in the center. If we scroll further down below at the very bottom of this web page, we can compare the long-term performance of our crops across various dimensions. We see that chickpea provides by far the highest gross margin, and none of our crops ever observes any crop failure. Sorghum achieves a much higher crop water uptake than mung bean, which again may be an important indicator for our analysis. Which performance dimensions you personally evaluate as most relevant is really strongly depending on your own circumstances. It will depend both on the environmental and socioeconomic characteristics of your farm. We then click on Explore Alternatives to navigate to the next section of the tool. This is also the end of the second RotationARM video that provided an overview of how to interpret the main results. The following tutorial video will focus on comparing the performance of this reference crop rotation to potential alternatives.